Hey YouTube, this is Kyle from Mr. K's Math and Science channel. Today's video is on spectroscopy. The study of spectroscopy is essentially how matter interacts with electromagnetic radiation. In spectroscopy we have two different phenomena we look at. We have absorption and emission. Absorption occurs when we have a discrete and quantized electron jump from the ground state to the excited state. Emission is a discrete and quantized electron jump from an excited state to a ground state. In the graphic to the right, we have absorption symbolized. We have an electronic energy level E1, electronic energy level E2. We have an electron in the E1 energy state. Off to the side, the squiggly line that symbolizes electromagnetic radiation coming in. HV, that's Planck's constant, and B is frequency, also known as nu, the Greek letter nu. When you multiply those two values together, you get energy. So the equation is E equals h nu. So when that EMR comes in and interacts with that electron, it provides a source of energy. Well, that electron gets excited. Therefore, it jumps up to the E2 energy level. The same can happen in a process called emission, where now you have an excited electron and now it's looking to relax. So it kicks off that photon or that packet of energy and relaxes back down to the ground state. There's a number of different types of spectroscopy, and it's important to note that not all spectroscopy causes electron transitions. Electron transitions typically occur in higher energy spectroscopy, or when high energy radiation interacts with the matter. Typically everything above ultraviolet visible light causes some sort of electron transition or destruction of the atom or molecule. Some other types of spectroscopy include X-ray spec, ultraviolet or visible spec, IR, microwave, nuclear magnetic resonance, mass spec, gas chromatography mass spec, scanning electron microscopy, or scanning tunneling microscopy. X-ray causes destruction typically, or it can penetrate an atom's core electrons and cause transitions or cause them to leave the atom. Ultraviolet vis, these are where we see electronic transitions. So electrons are typically in some ground state or a low electronic state. When this radiation comes in, the atom is excited. The electrons then have sufficient energy to jump to the next electronic state. IR, we see a lot of infrared spectroscopy. We use this to measure certain functional groups in molecules. Microwave spectroscopy, that's used to measure rotations. Nuclear magnetic resonance, this takes advantage of the nuclear spins on certain atoms. Typically there's a lot of proton NMR, but you also have carbon-13 NMR and some others. Mass spec, that essentially separates molecules by their mass. Then you have gas chromatography mass spec. So gas chromatography, we can use a gas cell to heat up molecules to get them into the gaseous state. Then we can send them through a mass spec. If you have any questions or comments about this video or would like to suggest content for future videos, send me an email at stein51687@yahoo.com. Thanks for watching. Be sure to subscribe.